Welcome back to Miller's Construction. Have you ever had an issue with water in your garage? Has it ever caused catastrophic damage or structural damage? Well, that's what the project we're on today. And I'm going to show you how we addressed the issue of water management, why this garage was built wrong at the very beginning to begin with, and what you can do to fix your garage if you've got water issues in your garage. So this is a 3-car garage, 9-foot doors on the ends and a 10-foot door in the middle. And this garage addition was built probably about 30 years ago. Yes, this is an addition to the original home. And we've got a few issues here. First, let's go around to the outside. So this run of gable wall, as you can see, it's pretty low to the ground. Well, they had landscapers come in and pour this concrete, put pavers in, and then in this section right here, we had shrubbery and mulch, and it was literally piled up against the siding. It was so damp that when we pulled the siding off, the vinyl siding, we actually found a dead crawdad at one point in time. So that just tells you how much water was an issue in this section. So it's a pretty obvious thing here. The very first problem is that it was built too low. Okay, the new client, the client that's living here now, realizes he needs to get the water away from his house, and the best way to do that is to grade it properly. So I'm not sure if he's going to take the sidewalk out. I advised him to, because it's basically holding water in here, but he is going to cut some trenches underneath it and put some big pipes in. So hopefully that'll help, and he's supposed to get all of this dirt out of here, make it a little bit lower even yet. But this entire bottom plate of this entire wall, it was a double bottom plate, and whoever built this, they put 2 bottom plates on. They were untreated, and they didn't put a single anchor or fastener in the entire thing all the way down through here. It was relatively easy to demo this specific section of wall. So let me show you how we fixed it, because this wall was literally just hanging in the air. Thankfully, it's a gable wall, so the truss is spanning from one side to the other, so it's not necessarily a load-bearing wall. So it might have looked scary in the videos and the pictures that I've posted, but it really wasn't that big of a deal. Did it need to be fixed? Absolutely. It is structural, but it's not as important as if it would have been a load-bearing wall. So if you'll come inside, we'll show you what we did to fix it so far. And we've got kind of a cluttered mess in here because we're still working on this project, obviously. But if you come down here, and we've got a bunch of insulation piled up, you can see that we essentially cut off the studs at about 16 inches up. That gave us enough room to get our rotary hammer and tools in there to secure a new treated bottom plate. So this new treated bottom plate, we embedded that into a very thick bead, a generous bead of Lexel from Sashco. Wonderful stuff. If you haven't used it, you definitely should. It adheres to almost anything. So the first upgrade we did was a treated plate, obviously, and then we did Lexel underneath that treated plate, and then we put anchors all throughout. Here's an anchor right here. There's one right over there. So we've got anchors in it. So essentially what we've done is we've restructured or reframed this with like a little pony wall, or a little stem wall, if you want to call it that. So we just essentially did away with the entire bottom plate. We considered scabbing onto the existing studs, because I know some folks might talk about like a pinpoint, maybe that wall kicking out at some point in time. But we didn't feel like that was necessary. We didn't want to take down the rest of this finished wall. It's all insulated, and the insulation is good in there. We didn't want to take down structural sheathing that was fine on the outside. And to add to that, if you look over here, the structural sheeting we replaced, it actually connects the bottom plate up to the studs. So we've got a nice connection there. There's no difference in that connection and the connection that you might see from a first story to a second story, where a framer bonds the studs from the first story to the second story with a full 4x8 sheet of plywood, or OSB in this case. So we feel really good about that. We're essentially spanning the top plate, our new top plate with that. So, and the fact that it's a gable wall, we're just not too worried about it. So those are a couple things you can do. When all else fails, just cut the bottoms of the studs off, get that bottom plate out of there, put your new treated bottom plate in, and put some sealant underneath it. But that's not all we're going to do. Come back out here and I'll show you something else. Now we're gonna approach this with kind of a belt and suspenders approach. Is that good enough? It's not for us. We're gonna go with a few more phases here. This is just the very beginning. If you'll follow this line, you can see that our new OSB sheathing is actually overhanging the concrete slab slightly at the bottom. But if you'll follow that down here, you can see we start to get a lip and it continues. That lip just gets larger and larger. Come on down here and we'll show this off. You follow that concrete down there and it just gets wider and wider and wider until down here we're at approximately 2.5 inches. So we go from nothing to about 2.5 inches of concrete slab exposed. How are we going to handle that? How are we going to get that water out of there, keep it out of there if it were to get behind the siding? The very first thing that we're going to do is we're going to use a new product from Typar. It's a liquid flashing product, and we're going to completely coat the connection between the OSB sheathing and the concrete. That'll create a real nice bond that will be watertight, okay? So we're going to slather on that Typar on the top of the slab and up that OSB wall just a little bit. That's the first step. Next, we're going to come back while the liquid flashing is still wet, and we're actually going to set what I'm going to call a drip cap in that liquid flash. So we're going to have to bring our Tapco metal brake out here, and we're going to have to custom bend a drip cap that will have a wall leg, and then it will have a beveled cap on top, and then it will go down the concrete just a hair. Just like you'd see a drip cap over a window or a door. We're going to take this wall leg up several inches to get up out of the water, right? Then we're going to take our Typar drainable house wrap and put over the whole thing, and that will get us fairly tight. But we're also going to do one extra step. Because the vinyl siding is what this client has on this home is so low to the ground, we want to get that vinyl up out of the ground for multiple reasons. One of the main reasons is like a string trimmer or anything that could possibly damage that bottom piece of vinyl. We want that out of there. So we're actually going to put a piece of PVC, like 5/4 stock, like an S4S PVC board at the bottom, put a drip cap on that, then start up with our vinyl siding. So that will be our exterior detail. Let me show you a little bit more with some structural issues we had. So around the front of the home, this has manufactured trusses spanning from the back wall all the way here to the front. We've got 3 columns here, and all 3 of these are obviously load bearing. The problem was this pad that they poured or they built on top of all kind of drains towards the bottom plates that were sitting slap dab on the concrete, and you guessed it, no anchors in them, not treated, just right on the ground, okay? Recipe for disaster. We've got a control joint down here. This slab is sloping towards the garage, so any water that collects, it was hitting the bottom plate. Same for inside in that control joint, so you can kind of see what we've done here. Another issue is the fact that they built all of this on top of no footing. There was no footing at all. So the contractor, I don't know if he just trusted the client that there was a footing under there, or they didn't verify it either way. I was able to stick my flat bar underneath this portion. And you can see now this is concrete because we poured a footing. But before we poured that, I was able to stick my flat bar underneath it and verify that there was no footing. And when we put a level or a laser on this, we could tell that the slab had sunk slightly from the pressure of this load-bearing support wall. So we knew we were going to have to put footings underneath it. That's the right way to do it. So we ended up actually cutting this entire section out underneath. We cut the wall off up top, put jacks in just like we did down here, and supported the entire roof. And we've actually got this false wall behind us. All this is for our protection, to make sure that we are supporting the load that's coming off of this or coming over here while we work on walls that we had to cut out. Hopefully that makes sense. So we cut that out. Our frost depth is about 10 inches here, so we went 14 inches deep. with some structural concrete. It dries to 6,000 PSI. Really, really nice stuff. We put 5/8 rebar in it. And then we formed up about a 2x6, about 5.5 inches. And that's what you see here. So essentially you've got a monolithic stem wall. So it is actually tied in with the footer. Come down here, you can kind of see that in action a little bit. So this one we just poured yesterday. So this stem wall is up out of the ground. The point of this is to get the wall, the bottom plate. We want, even though this is a treated bottom plate and we treated just like the other, we put Lexcel underneath it. We want to get this bottom plate up out of the water, okay? We want to get the siding up out of the water. So we poured that 5.5 inch stem wall. Now we're up out of the water. We've got concrete. It's not going to hurt concrete if it gets a little wet here and there. But that's how we attacked it. And you can see that this is just floating here. We've got our jack protecting us and our false wall. But you can kind of see how we've done it, and I think it turned out really well. So down here you can see that the client has vinyl siding right next to the slab. They don't want to touch that right now. We don't know if there's any structural damage there or not. But one thing that the client requested, we were just going to set blocks. That is an alternate method for you if you're trying to do it a little bit less labor intensive and a little more economical. Instead of having, if you know that there's a footing down there, that would be kind of hard to cut out and you don't want to form up for concrete piers. You could effectively just lay blocks, standard foundation blocks, and get that wall up out of the water. But we've got an issue here with that. We've got our garage door openers that would kick the inside in just a little bit. You got to think about those things because the standard block is about 8 inches wide. So we would effectively have to reframe the inside to get the garage door frame or brackets tied in at the correct plumb level, or plumb position, I should say. So we didn't want to go with blocks for that reason, but we also didn't want to go with blocks because the client didn't think that it would look good. They didn't want exposed blocks down there. Well, I know what you're thinking, you've got exposed concrete now. Here's how we're going to remedy that to kind of tie that in with the rest of the house. We're actually going to adhere some 5/4 PVC to this, then start our vinyl siding up. So down here you can see that our structural sheathing is actually sitting on the lip of this concrete that we just poured. What we're going to do is we're going to attach a 5/4 PVC board, put a drip cap on top of it, then start our vinyl siding up, and that will kind of blend in with the rest of the home and it won't stick out like a sore thumb. So that's our plan. Then we can wrap this with coil stock just like they had originally. I really hope this helps you folks. It can be dangerous when you're dealing with structural repairs. Just make sure you protect yourself. Build a false wall like this. We did verify where each truss was, and we put the studs underneath each truss so that we knew we were hitting contact. We weren't just going to blow through this OSB ceiling up here. There's a lot that can go into this. I would recommend hiring a professional contractor or carpenter to take care of this. And sometimes it's going to be required to get an engineer involved or get a set of plans, get city approval. We're in a rural community here. We don't have to do any of that stuff. So common sense kind of comes into play. So that's why we did it the way we did. Once again, don't worry about the pivot point right here. If you'll come around here, you can see we essentially did the same thing. So we cut off, we've got a top plate, and then we've got our studs down. The thing about it is we've got structural sheathing 8 foot all the way up to here, tying all of that together. So we're really just not worried about that pivot point. We feel like the structural sheathing is going to tie it together and do its job. So really hope this helps. If you have any questions, please leave me a comment down below. I'd be happy to assist if there's any way I can. I know that a lot of garages are built kind of low like this and have issues, so that's why I thought I'd make this video, kind of show you the process of how we've been attacking this one. Don't forget to like and subscribe if you enjoyed this video, and we'll see you on the next one.